Marine biologists once accused ocean sunfish specimens of being elaborate hoaxes. After all, here was a fish so absurd it looked stitched together from leftovers. No tail, no defenses, barely enough brain to swim straight. Everything science knew about survival said this creature should have vanished ages ago. So how did a fish that broke every rule of evolution conquer every ocean on Earth? The answer begins with a missing tail and a mystery that infuriated Victorian science. Victorian naturalists prided themselves on their ability to classify every living thing, but the sunfish tested their patience and their imaginations. Letters circulated between London and Paris, filled with exasperated sketches and sarcastic jabs. Here was a fish that defied every blueprint in the scientific catalog. Its body ended not in a proper tail, but in a strange, truncated paddle. No smooth lines, no powerful fins, just a blunt, towering slab with eyes set too close together and a mouth that seemed to serve no purpose. The debates spilled into museum halls where curators argued over whether the sunfish was a trick of preservation or a genuine product of nature. Some compared it to the platypus, another animal that had once been accused of being a stitched-together prank. The sunfish, with its lumpy silhouette and awkward proportions, seemed almost as unlikely. A few skeptics even suggested someone had joined the front of one fish to the back of another, perhaps as a joke at the expense of European science. Yet the evidence kept arriving. Strandings along the British coast delivered specimens that were impossible to ignore, massive, heavy, and undeniably gill. The British Museum's Albert Gunther, a respected ichthyologist, examined one and called its form absurd, but he could not deny its authenticity. Detailed dissections revealed a true anatomical oddity, not a hoax, but a fish so unconventional that it seemed to thumb its nose at every evolutionary principle the Victorians held dear. Public fascination soared. Newspapers described the sunfish as a monstrosity and a marine enigma, while children pressed their faces to glass cases, hoping to glimpse the giant whose body looked more like a kitchen appliance than a living animal. Scientific journals filled with heated exchanges about its place in the tree of life. Was it a failed experiment of nature, or proof that the ocean still harbored secrets too bizarre for textbooks? The sunfish's arrival forced a reckoning. If such a creature could exist and thrive, what else might be lurking in the depths, waiting to upend the rules? Victorian science, so certain of its categories, suddenly found itself staring at a living contradiction, and the mystery was only just beginning. A fish without a tail is like a bird without wings, yet the sunfish seems unbothered by this missing piece. In most fish, the tail is the engine, a sleek, muscular blade that powers each surge forward. For the sunfish, that crucial appendage simply vanishes. During its larval stage, the tail is present, but as the young sunfish matures, the tail is reabsorbed, leaving behind a peculiar structure called the clavus. This is not a fin in any classic sense. It is a stiff, paddle-like rudder, more suited to steering than speed. The real work falls to the dorsal and anal fins. These two unpaired fins, set like oars above and below the body, flap in perfect synchrony. Instead of undulating its body like a tuna or a shark, the sunfish relies on these fins to generate lift-based thrust. The movement is less like a fish darting through water and more like a bird flapping its wings, except this bird weighs over a ton and never takes off. Biomechanics studies reveal a system that, on paper, should barely move at all. The sunfish's body is a thick, gelatinous capsule, nearly 90% water, wrapped around a skeleton that lacks the robust muscles for rapid swimming. Inside, a fibrous septum anchors the fin muscles to the skull and backbone, channeling power to the fins through a web of tendons. When the dorsal and anal fins sweep up and down, they flex and change shape, acting like hydrofoils to push the fish forward. The clavus, meanwhile, acts as a simple rudder, tilting to steer but contributing little to propulsion. The result is movement that is slow, deliberate, and undeniably awkward. Instead of slicing through water, the sunfish drifts, sometimes tilting sideways, sometimes rolling, and always looking as if it is searching for a manual. Juvenile sunfish can swim faster, beating their fins in rapid bursts, but adulthood brings a shift. As the fish grows, the fins lengthen, the body thickens, and the swimming style settles into a lazy, pendulum-like rhythm. There is no sprinting, no sudden turns, just a steady, almost stubborn persistence. Observers have described the spectacle as a dinner plate gliding through soup, propelled by two mismatched spatulas. And yet, despite all appearances, this strange system is enough. The sunfish covers thousands of miles, crosses entire oceans, and manages to survive in a world where speed is supposed to mean everything. For the sunfish, movement is not about grace or power. It is about getting by with the bare minimum, an evolutionary shrug that, somehow, works. Parasites do not just cling to the sunfish, they set up camp. More than 40 species can inhabit a single individual, from tiny copepods to worm-like nematodes, each finding its own patch of thin, mucus-covered skin. Barnacles drill in, sea lice burrow, and flatworms glide across open wounds. At first glance, this looks like a death sentence. Most fish would not survive such an onslaught. Yet the sunfish is not overwhelmed. Instead, it has become the centerpiece of a bustling parasite economy, a floating ecosystem that rarely stands still for long. Field researchers in the Mediterranean and Pacific have documented these fish drifting near the surface, tilting their massive bodies upright, almost like a signpost in the middle of nowhere. This is no random act. The sunfish is advertising itself as a cleaning station. Smaller fish, including wrasses and angelfish, dart in and out, picking parasites from every crevice. In tropical reefs, these cleaning partners work methodically, sometimes for hours, scouring the sunfish's skin and gills. Even in the open ocean, far from any reef, the sunfish finds help. It floats just beneath the surface, exposing its flanks to passing seabirds. Gulls and cormorants swoop down, landing directly on the broad, flat body, pecking away at parasites that would otherwise drain the sunfish's strength. Some birds have been seen riding the sunfish for minutes at a time, feasting on the bounty of invertebrates. This routine is not a rare event. High-speed footage from research teams shows sunfish returning to the same cleaning spots again and again, sometimes forming slow-moving lines as they wait for their turn. In one study, a single sunfish hosted more than 97 different types of parasites, yet showed no signs of fatal infection. The sunfish's immune system seems to tolerate these unwanted guests, while its behavior ensures that the worst infestations are kept in check. The open wounds and missing patches of skin are simply part of life, a trade-off for carrying a mobile cleaning crew wherever it goes. By turning itself into a living apartment building, the sunfish has transformed vulnerability into resilience. It cannot prevent parasites from settling in, but it can manage the problem, outsourcing the cleanup to others. In the process, it supports an entire community of smaller species, making its own survival inseparable from the health of the ocean's cleaning networks. What looks like weakness is, in fact, a quiet kind of strength. An alliance formed not by force, but by mutual need. A brain the size of a walnut sits inside a creature that can weigh more than a car. The sunfish has one of the lowest brain-to-body ratios of any vertebrate, less processing power than a goldfish, less cunning than a garden slug. Yet somehow this vacant stare is all it needs. The secret is not intelligence, it is abundance. The sunfish does not waste energy plotting, strategizing, or chasing elusive prey. Instead, it drifts through the water, mouth agape, on a never-ending search for one thing: jellyfish. Jellyfish are the ocean's leftovers. They are little more than water and collagen, floating in huge, gelatinous clouds. Most predators ignore them. There is hardly any protein, almost no fat, and a mouthful of stinging tentacles for the trouble. But for the sunfish, this is an all-you-can-eat buffet that never closes. It does not need to be clever. It only needs to keep swimming, slowly and steadily, through the endless jellyfish blooms that pulse across the world's oceans. A sunfish spends nearly every waking moment eating. Its day is a simple routine: drift, find jellyfish, eat, repeat. There is no hunting technique, no ambush, no chase. The fish simply bumps into food, swallows it, and moves on. Some researchers have measured sunfish with stomachs packed full of jellyfish, hundreds in a single gut. The energy payoff is laughable. Jellyfish are about 95% water. To put on a single pound of weight, a sunfish must consume an astonishing volume of these ghostly snacks. But that is the genius of the strategy. Jellyfish are everywhere, and nobody else wants them. Instead of burning calories on high-speed pursuits or elaborate escapes, the sunfish invests in patience. It lets the current do most of the work, drifting from one jellyfish patch to the next. Its body is built for minimal effort, no fuel wasted on unnecessary movement, no need for a big brain to solve complex problems. The fish is a model of evolutionary efficiency, an enormous, slow-moving stomach on a mission. In a world obsessed with speed, power, and intelligence, the sunfish survives by doing almost nothing and doing it very well. Its greatest strength is its ability to keep going, hour after hour, mouth open, scooping up the ocean's most neglected resource. The sunfish's buffet strategy is not glamorous, but it is relentless. And in the end, that is more than enough. Sharks patrol the open ocean with little concern for what crosses their path. When a sunfish appears, it is an easy target, slow, oversized, and seemingly defenseless. Great whites Makos, even smaller blue sharks have all been documented taking bites out of sunfish flanks. Sea lions and orcas join in, treating the sunfish less like a threat and more like a floating buffet. Drone footage from Australia shows sea lions tearing strips from a sunfish's side, leaving wounds large enough to see from the air. In California, a tagged sunfish surfaced with a gash so deep it exposed the gelatinous tissue beneath, a wound that should have spelled the end for any ordinary fish. But the sunfish is not ordinary. Its body is built less like a streamlined missile and more like a padded tank. The flesh is thick, spongy, and packed with collagen, forming a kind of living armor. Instead of vital organs running the length of the body, everything important is tucked deep in the center, out of reach from most attacks. A shark can bite off 20 pounds of flesh, roughly the weight of a car tire, and the sunfish will simply keep swimming. The missing chunk closes over in weeks, leaving a scar but no sign of infection. Laboratory studies have measured sunfish tissue regenerating at rates that rival much smaller, faster healing fish. The wounds do not fester. They close cleanly, the skin knitting itself back together as if nothing happened. Photographs from marine biologists show sunfish with old bite marks, jagged scars, and missing fins, all healed over. One sunfish was tracked for months after losing nearly 1/10 of its body mass to a predator. Not only did it survive, it gained weight, continuing its slow migration across the Pacific. The sunfish's resilience is not about fighting back or escaping. It is about being too big, too tough, and too quick to heal for predators to finish the job. Attackers get a meal, but the sunfish gets to live another day. In the open ocean, this endurance is its only real defense. There is no chase, no display of aggression or speed. The sunfish absorbs punishment, recovers, and moves on. What looks like helplessness is actually a survival strategy, an evolutionary bet on size, regeneration, and the ability to take damage that would destroy almost any other fish. A single female sunfish can release up to 300 million eggs in one spawning season, a number so large it is almost impossible to picture. In the world of vertebrates, nothing else even comes close. Most fish hedge their bets with thousands, maybe tens of thousands of eggs. Salmon, the poster child for prolific reproduction, lay around 5,000. The sunfish is playing an entirely different game. Each egg is a lottery ticket, and the odds are brutal. Almost every hatchling will vanish, devoured, starved, or swept away before it can even grow a tail. But with numbers that high, a few survivors are all it takes to keep the species going. That is not just insurance, it is a strategy that has paid off for millions of years. Modern technology has pulled back the curtain on what happens after those eggs are released. Satellite tagging, pioneered by researchers like Tierney Theis, has tracked sunfish across entire oceans. These fish are not passive drifters. They are marathon travelers, swimming thousands of miles from spawning grounds to feeding zones. One tagged sunfish crossed 1,800 kilometers in just a few months. Data loggers have recorded dives to more than 2,600 feet, down into the twilight zone where sunlight fades and jellyfish gather in thick, drifting clouds. The sunfish follows its food, rising and falling with the daily rhythms of the deep sea, sometimes plunging into water cold enough to numb a human hand in seconds. It is not just the scale of reproduction or the scope of migration that stands out. The sunfish holds the record as the heaviest bony fish ever measured, with individuals tipping the scales at over 5,000 pounds. Yet this heavyweight champion, often dismissed as a slow-witted oddity, has mastered a lifestyle that most predators cannot touch. By laying more eggs than any vertebrate, by traveling farther and diving deeper than anyone expected, the sunfish has made itself almost impossible to wipe out. It does not matter if most eggs never make it. It does not matter if predators take a bite or two along the way. There will always be more sunfish, drifting and diving, quietly winning the evolutionary lottery year after year. For decades, scientists underestimated just how active and widespread these fish are. Now, with every new tag and every record-breaking dive, the evidence piles up. The sunfish is not just surviving, it is thriving on a scale that rewrites the rules of what it means to win at evolution. Right now, the ocean sunfish glides through every major sea. Proof that evolutionary success is not always about perfection, but persistence. As human pressures rewrite marine ecosystems, the sunfish's improbable triumph reminds us nature rewards the unexpected. Adaptation wears many faces, and sometimes the survivor is the one nobody bet on. The ocean still has room for the rule breakers. Share your thoughts below.